Welcome back. In the previous lecture, we had seen if statement, if else statement, and if else statement. Today we will see another selection statement, switch case. Switch case statement is used to compare the value of a variable with multiple values and execute some statements based on the match. Switch case statement has following syntax. It starts with switch, then opening round bracket, expression, closing round bracket, opening curly bracket, multiple case blocks, default block, and finally closing curly bracket. Over here, if the value of the expression matches to constant 1, then execute this block. If the value of the expression matches to constant 2, then execute this block. But if no match is found, then execute the default block. Note, no curly brackets for case blocks, even in the case of more than one statement. This is different from if-else statement. All the case block statements are optional, including break, which means blank case block is perfectly legal code. We will see an example of blank case block at the end of this lecture. And finally, default block can appear anywhere in the code. It should not be the last one. It could be the first block inside switch, or it can appear anywhere in the middle. We will see an example on this as well. Before we actually see an example of switch case, let us first see an if else solution. This program prints Monday when day code equals to 1, Tuesday when day code is equals to 2, and so on. Logic is quite simple. We have a day variable which is initialized to 1. If day double equals 1, then print Monday. If day double equals 2, then print Tuesday, and so on. Print all the days of a week. If the value of day is not between 1 and 7, then print not a valid day. Let us check the output. The day value is equals to 1. Run it. You can execute a Java class by clicking on run and run or pressing Ctrl F11. The output is Monday. When the value of day is 6, save it, run it. Output is Saturday. When day double equals 6, output is Saturday. When day is 8, save it, run it. Output is not a valid day because the value of day is not between 1 and 7. So in this case, else block gets executed. Let us implement the same solution using switch case. Let us open another file, _0 to example.java. We have a day variable which is initialized to 1, same as previous code. Now let us start writing the logic using switch case. Write switch, which takes day variable, opening curly bracket, press enter. Eclipse will provide you with the closing curly bracket. We will be matching the value of day variable to all the case constants here. Let us write the first case, case 1, colon, press enter, sys out. When the value of day is 1, print Monday. Write break, case 2. If the value of day is 2, print Tuesday. Sys out, break. Let us copy and paste for other cases. Cases 3, Wednesday. Cases 4, Thursday. Cases 5, Friday. Cases 6, Saturday. Cases 7, Sunday. Save it. Generally curly brackets are not used with case block, but let us try to use one. Over here, opening curly bracket and closing curly bracket. Let me indent it properly. Save it. So even if we use curly brackets for case block, there is no compilation error. And finally default block, colon, sys out, not a valid day, and then finally break. Save. We are finished with our logic. Let us check the output. When the value of day is 1, output should be Monday. Let us run it. So the output is Monday. So what is happening at runtime? In this case, when a switch is encountered, Java runtime first evaluates the switch expression, in this case variable day, which is 1. Then control jumps to the case whose value matches the value of the day variable. In this case, this is the first case block because the value of day variable is 1. System.out.println statement gets executed, which prints Monday onto the console. Then we have a break statement. This takes the control out of the whole switch case block. The main method ends and the program ends successfully. Now let us check the output. When the value of day is 6, save it, run it. The matching case is found. This statement gets executed, which prints Saturday to the console. Then there is a break statement, which will take the control out of the switch case block. Then the main method ends, and then the program ends successfully. But if none of the cases are satisfied, then in that case, default block would get executed. Let us check this scenario as well. When the value of day is 8, save it, run it. In this case, the default block is getting executed, which is printing not a valid day to the console. This solution is similar to previous if else example. You should remember few important points here. The switch expression can accept following: char or character, byte or byte, short, or int or integer. So these are primitive types: char, byte, short, and int. And character, byte, short, and integer are wrapper classes and will be covered in later lectures. And enum only from Java 6, enum will also be covered in later lectures. And a string expression only from Java 7. Now as far as the case values are concerned, these must evaluate to the same type or compatible type as the switch expression can use. And these must be a compile time constants. We will see these 2 points in next example, but before that, let us first understand compile time constant and final keyword. Let us first check this statement. So this will create a memory location of integer type. Its name is n1 and the value to which n1 is initialized is 5. Now what is the meaning of final over here? Final means once the value is assigned for the first time, it cannot be changed. So if there is another statement, say n1 equals to 10, this will give a compilation error because this is a constant memory location. Same thing in this case as well. We are creating an int memory location. Its name is n3. This is a final memory location, but it is still not yet initialized. In the second statement, when we say n3 equals to 20, the memory will be initialized to 20 for the very first time. Now after that, we cannot change the memory location. Suppose if there is a statement n3 equals to 2, this will also not compile because this memory is a constant memory location. Now there is some difference between n1 and n3 and we will see it on the slide. Let's go back to the slide. So which values are compile time constant? Literal values used directly are compile time constant. In this case, 100 is a compile time constant. Declaration and initialization using final keyword in a single statement creates compile time constant. So over here, n1 and n2 are compile time constants. Both are final and declared and initialized in a single statement. But n3 is not a compile time constant. Even though the final keyword was used, but n3 was assigned in another statement, not on the same statement. Any mathematical expression involving compile time constant will also be a compile time constant. So in this case, n1 plus n2 is compile time constant because both n1 and n2 are compile time constant. On the same lines, n1 multiplied by n2 is also a compile time constant. As literal values are always compile time constant, hence their mathematical expressions are compile time constants as well. So in this case, 8 plus 15 is a compile time constant as well. Now n3 is not considered as a compile time constant, so any expression involving n3 will also not be considered as a compile time constant. So over here n1 plus n3 is not a compile time constant. Now the last point you need to remember is switch case blocks can only check for equality operator and not other relational operator such as greater than equals to, less than equals to, or other relational operators. Let us check few more examples on switch case. This example shows case values must evaluate to the same type or compatible type as the switch expression can use, and case values should be compile time constant. So we have a main method. Inside that we have a byte variable var which is initialized to 65, final byte variable a which is initialized to 10 in the same statement, final byte variable b but it is initialized in another statement. Switch expression is of byte type. Now first case, we are using a variable a. Now because the variable a was declared and initialized on the same line and it is of final type, hence it is considered as a compile time constant. And the value of a is 10, which is well inside the byte range. So it is a valid case and we are not getting any compilation error over here. Now let us consider another case, a multiplied by 5. A is a compile time constant, literal is a compile time constant, so this whole expression is also a compile time constant. Its value is 10 multiplied by 5 equals to 50, which is also well inside the byte range. Hence, this one is also a valid case block. Now let us consider this case block. Save it. Now what is happening over here? A multiplied by 50 is a compile time constant because A is a compile time constant and literal 50 is a compile time constant. So this whole expression is a compile time constant. But its value 10 multiplied by 50 equals to 500 is outside the byte range. Hence, it is not allowed here because the case constants must evaluate to the same type or compatible type as the switch expression can use. So the switch expression is of byte type, so it should also come within the range of the byte type. So over here we are getting compilation error. The error is cannot convert from int to byte. What about this case? Let us check. Save it. Now b variable is of byte type. It is final even though it is a constant, but it is not a compile time constant because it was initialized on another statement. Hence cannot be used as a case constant. The case expression must be constant expression. What about this case? Do you remember character from your previous lectures? This is a Unicode value of character A and the decimal value of 65. The 65 is well within the byte range and it is a character literal, hence a compile time constant, so it is allowed over here. What about this case? This is also a character literal. It represents a Indian rupee symbol, but its decimal value is 8377, which is well outside byte range. Hence, it is not allowed over here. You can check the compilation error. Type mismatch cannot convert from char to byte. Over here, the conversion from char to byte was implicit, but over here, as the value is well outside byte range, hence implicit conversion is not happening. Let us run this program. The value of var is 65 and the matching case is this one because the decimal value of 65. So we should see 5 printed onto the console. You can also run a program by pressing this toolbar button. Press it and the output is 5. Let us check another example on switch case. This program displays traffic light colors using following logic. If color code is capital R or a small r, then print traffic light is red. If color code is capital O or a small o, then print traffic light is orange. And if code is capital G or a small g, then print traffic light is green. And in all other cases, print invalid color code. Solution is very simple. We have a string variable color code to store the color code. Initially, it is initialized to small o. Switch statement and the switch expression is of string type. From Java 7 onwards, we can use a string in switch expression. If color code matches to capital R, then print traffic light is red. If color code matches to small r, then also print traffic light is red. Print traffic light is orange for both capital O and small o. Similarly, print traffic light is green for both capital G and small g. But if color code is different from these 6 codes, then print invalid color code. Let us check the output. Color code is a small o. You can also execute a Java program by clicking on this run toolbar button. Click on it, it displays traffic light is orange because for a small o matching case was found. Printed this statement, the break statement is there. It takes the control out of the switch case block and the program ended successfully. Let us check the output for capital G. Save it, run it. Traffic light is green. For capital G, matching case was found. This statement got executed and after that break takes the control out of the switch case block. The main method ends and the program was ended successfully. Let us check the output for small a. Control S, run. In this case, no matching case was found. Hence, default block was executed, which printed invalid color code to the console. Now, the position of default is not fixed. It can appear anywhere within the switch block. Compiler first checks for the matching case blocks, and if no match is found, then only the default block gets executed. If I move the default block at the top, save it, let us run it. We get the same output. In this case, no case constants were matched, hence default block was executed. which printed invalid color code. The break statement takes the control out of the switch case block. The main method ends and the program ended successfully. Let us verify the same logic using valid color code. Small r, control S. So this case block was executed and it printed traffic light is red onto the console. Let me move the default block somewhere in the middle after orange. Control S. Let us check it for A, invalid code. Control S. Run it. Again we are getting the same output, invalid color code. So the position of default is not fixed. It is different from if else, in which else should be the last statement. Let us see another example. This example is same as previous example, except that the break statements are removed. Let us check the output for a small o. Run this program. So it first prints orange one and the green statements twice. So what is happening here? The Java runtime first evaluates the switch expression. In this case, it is color code which is pointing to small o. Then the control jumps to the matching case block. So in this case, it is this case block. From this point onwards, Java runtime executes all the statements in top to bottom order until a break statement is encountered or the whole switch case block ends. So in this case, it executes this statement which prints traffic light is orange to the console. Then it executes this statement which prints traffic light is green to the console. And finally, it executes this statement. This also prints traffic light is green onto the console. And after this, the whole switch case block ends, the main method ends, and the program was terminated successfully. That is why we see these three statements onto the console. This scheme is also known as fall through. If you are planning to appear for Java certification, then expect few questions on fall through in the exam. If you are not using break, then the position of default will affect the output. Here default is the first block. Change the color code to B, save it, run it. In this case, none of the cases are satisfied. Control enters the default block. It executes this statement. And because we are not using break, so it will fall through all the statements. So it will start executing all the statements from top to bottom. So this was executed first, invalid color code, then this statement and all the remaining statements in this order. Now let us move default as the last block. Control X, Control V, save, run this program. This time it prints invalid color code only. None of the cases are satisfied over here as well. So the control enters the default block. It executes this statement and there are no other statements to be executed. The whole switch case block ends, the main method ends, and the program is terminated successfully. Let us now check an example that shows meaningful use of fall through. In this scenario, for capital R, we have not provided any statement, but provided a statement for small r. So let's see what happens at runtime. Color code is capital R. It will match to the case with capital R. Java control enters this block, but there is no statement to execute and there is no break as well. So it will move ahead and execute all the statements till it encounters a break or the switch case block ends. So it executes the system.out.println statement. Traffic light is red will get printed to the console. After that, the break is there, so it will come out of the switch case block. Let us verify the output. The color code is capital R. Run it. It correctly prints traffic light is red. So for both capital R and small r, this code prints traffic light is red. For capital O and small o, traffic light is orange, and for capital G and small g, traffic light is green. By correctly using fall through, we can reduce some lines of code. So this example _04 example.java and this example _06 example.java are same as far as the logic and output are concerned. But _06 example.java uses less lines of code. With this, we have come to an end. See you in the next lecture. Till then, happy coding.